Okay, so this video is going to talk about naming ionic compounds. So before we get started, just a couple of things to remember about ionic compounds. They have to be a cation and an anion. You must have a positive and a negative that you're dealing with in order to follow these naming rules. Another thing to remember is, since we are dealing with charged particles here, the total charge of your compound must equal 0. It has to equal 0. So when we start combining our cations and our anions, we have to make sure that we end up with our positives and negatives canceling out. Last thing to mention with naming is, after you name your cation, if you have a variably charged cation, you have to make sure that you indicate the charge on that anion. Long story short, if there can be more than one possible charge, you have to tell which one you've used. So a few examples going from the formula to the name, the actual written out name. Something simple first, like magnesium or MgCl2. Told you the answer there. So if we wanted to name this guy, we have charges going. Magnesium usually takes a +2 charge. Cl usually takes that -1. First thing we name is our cation. Here, magnesium. There's only one charge that magnesium can take, so I don't need to indicate his charge because the one charge is all I have. So then on to the anion. In this case, it is chloride. So we took the root name of the element chlorine, that chlor, and we tacked on IDE. So the full name for MgCl2 is simply magnesium chloride. An example using a variably charged cation, perhaps something like, I don't even know, SO42. So again, first we name our cation, our positive here. It is in fact cobalt, and I know that cobalt can take a variety of charges. So I'm going to have to indicate what charge I'm using here. I don't know what it is yet, so we'll get back to that in a moment. For now, let's go on to our anion. This guy here is one complete package. I don't name the pieces individually because it is in fact a polyatomic sulfate. It is one chunk. It cannot be separated. So now let's go back and talk about that charge. I know my total charge has to equal 0, and I don't know anything about my cobalt yet. I do know that sulfate has a charge of -2. I have 2 of those sulfates, so that's a grand sum total of -4 charge that I have to get rid of and cancel out. Since I only have one cobalt here, that means my whole cobalt has to take on that +4 charge to give me the +4 to cancel out my -4. Thus, +4 is in fact the charge on my cobalt, and we represent that by putting a Roman numeral 4 in the parentheses next to my cobalt. So that is going from formulas to names. Let's try to go the other way. If we have a name such as ammonium oxide, and we want to write the formula, start with the cation there. This is in fact a polyatomic as well. This is NH4. He has a charge of +1. This is a poly, so this is a chunk. We have to leave it together, shrink wrap packaged all together. On to our anion. Oxide is O, and he has a charge of -2. Again, make sure compound totals to 0. -2 +1, that does not equal 0. That would be problematic. I need more positive charge. I can't change anything that's in this shrink-wrapped package, but I can have a second of those packages. Now, positive 2 plus negative 2 equals 0. We're good to go. I need to indicate that I want 2 of this plus 1 package. So my subscript of a 2 must go on the outside of my parentheses to indicate I want 2 of these. So NH4, 2O is the formula for ammonium oxide. Let's do one more. Perhaps, whoops, manganese. Spelling never was my strong suit. Manganese 3 sulfide. Let's go ahead and write the formula for this guy. Manganese is Mn. Your parentheses indicate your charge. So in this case, manganese has a plus 3 charge onto our sulfide, S. S has a negative 2 charge. Got to get to 0. Positive 3 plus negative 2, not 0. Well, I can't do multiples. I can get them both to 6. So to get to 6 here, I have to multiply this one by 2, this one by 3. So I need a subscript of a 2 next to my manganese, a subscript next to a 3 next to my sulfide. So Mn2S3 is the formula for manganese 3 sulfide. So in summary, things to keep in mind when you're naming ionic compounds. First, name your cation. Always name your cation first. If there is no charge indicated, there must only be one that it can be. If you have a charge indicated in parentheses, that's the charge that your ion is taking. After that, name or do the symbol for your anion. Use subscripts to balance your charges. When going from symbols to name, again, name the cation. If there is more than one possible charge for the cation, make sure you indicate that charge in parentheses, followed by your anion. There can be no parentheses or charge indicated on the anion. It is only ever indicated on the cation. So I hope that helps. If you have any further questions on this concept, please be sure to email me and let me know so I can help you out further. Thanks.